Hope you had a nice lunch and welcome to my talk. I think that conferences usually are a very good place where people come to learn about new things and maybe discover something. And what I'm doing here is kind of the opposite back to basics talk that conferences are guilty in people using a lot of not very needed practices in the teams. So we're going to talk about it here. So I come from. Okay, now something doesn't work anymore. Let me check. Wow, cannot switch the slides. Sorry about that. Okay, I'm going to just... Okay, now I can. So I come from a beautiful city of Tallinn, Estonia. So you're welcome to visit us. We are one of the pioneers in digital government and a big startup hub in Europe. We also by the sea. And I come from a company called Codeborne. We are a software services company in Estonia. So over the last 14 years, it gave me an opportunity to see hundreds of organizations from the inside and actually learn from them and see what mistakes are they doing and very often teach them how to be more productive. So in Estonia and abroad, we are known to be one of the most productive development teams. So the title of the talk, in other words, can be rephrased, how to kill your team's productivity. So usually at any conference, at any bigger developer gathering, half of the developers have less than 5 years of experience, meaning that very often people actually haven't seen if they were working for, using some practices for 5 years, or less than 5 years, probably they haven't seen that it can be done in any other way. So that's why I'm here. And many teams do choose stuff only because everyone does it. So they look at the conferences, they see, okay, the passwords are like this, so we probably also need it all. And every practice I'm going to talk about, it has its uses, it has its use cases definitely, but many of them are just overused. So it's much of it is about the developer experience. So developers actually should enjoy their work. So we want to enjoy our work, and it goes about many aspects. So it's about languages. Programming languages that we choose. So every programming language has own different level of abstractions and verbosity. Here we are most of us probably are coding in Java, but there are also other options available, including on the JVM like Kotlin and Scala and Clojure, whatnot. So then it's about the tools. It's what IDE do we choose, which version control system, which issue tracking. I'm a big hater of Jira, for example. That's definitely something like an example of a tool that will slow you down instead of helping you to proceed forward. And then the practices and processes that you use in your team. It's about meeting, of course, that we all hate, especially if they are too many and they are too long and not very useful. Then the reviews, all kind of stuff that we need to go through, and responsibility. So productivity and motivation in always goes hand in hand as well. So work that we do, and it's not only about the software development, any work that we do should be meaningful. So of course we all get salary and get maybe we can say we work for money, but I think there should be something else as well in our work to actually to do it for longer periods of time. You can do it for money for several years, but for longer time you need to see the meaning of your work. So you need to see and feel the value and progress. So what that means is that the best recognition of our work as software engineers is there is somebody using our software. So yesterday there was one speaker with a t-shirt that definition of done is working code in production. So this in production part is really important. This is when I feel that I'm doing something useful and meaningful, when I see that like there are like many people using my software. Until they don't use it, until it's only somewhere in the branch, not released, whatever, I don't feel the satisfaction, because it's kind of meaningless work until there is a value in it. And what I see, and I've been programming professionally for 24 years, I see that developers very often, like after maybe like 15, 20 years, they actually tend to stop code and become managers, or like tend to do something else. So they don't like programming anymore. And I'm a fan of coding. I really like coding. I really like beautiful code, solving the problems and whatever. And if you like don't have all these hurdles that you need to overcome all the time in your team, then actually you can enjoy it for a lot longer, maybe until you retire, and you don't have to stop coding just because like the organization doesn't support it to be enjoyable. So when we choose any practices, we need to always think on a scale of easy and hard. So basically you want to make easy things, like good things, easy, and you want to make bad things hard. So if you choose some practices that tend to like push you otherwise, then it's not going to be productive. So as you see the example of this labyrinth, people will use the straight path much more often than the not straight path. So that's just the case how life works. So it's also in our work is about convenient and inconvenient. So convenient things are done often. So and you need to encourage people to do more of the convenient and good things. So yeah. So valuable things must be easy and convenient. So if we also talk, like we're also a lot about agile, but not the agile that is the management buzzword like Scrum and whatever. So we've been using extreme programming practices right from the beginning in our company, and also before that we used to work for a bigger bank in the Baltic states. So we want to make these things easy that we find valuable, and the big value, what we, according to Agile, and that's true, is that we want to get quick feedback in everything. So the quicker, the shorter, the better. So we want to make everything small, like small features, small iterations, 1 week in our case, small commits. Then we want to be continuous, so we are like do the continuous integration, and that means that everyone is working on the same code base, and also the continuous deployment, so that everyone can see and touch and use our code and give us feedback as soon as they can. So it's also collaboration, so these things need to be easy, and also like keeping things simple, like automated tests, of course, continuous refactoring. This should be easy, otherwise people don't do refactoring if it's not easy. And overall, like lean software development says that eliminate waste everywhere. So if you see that you're wasting your time or energy or effort, money, whatever on something, then you need to eliminate that. So if you always think about anything that you introduce in your team as is it a waste or not, then it will help you to decide which practices you actually need and which actually are slowing you down. So now let's start with the version control systems. So version control systems actually is a really good thing that we have as software developers. Many other engineers still, they like copy their files or all the drawings or whatever, and have that this is version from 1st of March, this is version from 10th of March and whatever. It's very hard to track them. We have really good software that helps us. So if you have been longer in industry, probably you have seen maybe CVS and Subversion. These were like harder to use, and now we are blessed with Git and GitHub, which came actually from open source. And Git is really good at one thing compared to the other, like previous version control systems. It's very good at branching. And why this feature is there is because it comes from open source model of low trust. So Linus Torvalds created Git for the Linux kernel. And Linux kernel is where there are like tens and hundreds of people trying to get their changes merged there. And so there needs to be support for like quick review and lots of branches at the same time. So this is when you don't trust anyone, so you want to review really thoroughly every change that they are doing. And that is perfectly a correct thing to do in an open source environment. So, of course, what Git also does well is that it's easy to do very small commits, and you always need to write really good commit messages that respond to the question why. But what we now have with Git is now everyone is using one certain practice that is not very suitable for the high trust environments that we mostly work in when we have a team where people actually work together a lot, so they know each other, they like writing good code, so they are good quality engineers. So we are using the open source model of low trust. So we are using which practice? How is it called? Pull requests. So pull requests is the first anti-practice that I recommend avoiding to use unless you really know what you're doing and why you're doing it. And usually why means there is low trust. So look at this picture. From the one straight road, you get this kind of mess if you have pull requests. So you don't have any one source of truth anymore in your code base. You have many parallel realities that some of them, if they are short-lived, you are lucky. If they are longer-lived, then it can become a mess. So it's an open source model, and it works for open source. It may work for external contributors from other companies until you build the trust. It may also work for junior developers who also you don't trust them yet to do the changes. But for the good working team, this practice slows you down a lot. So the goal, of course, is to do the code reviews. And code reviews are a good thing. So it's bad if only one single person does something in a change and nobody reviews it. But it's also mostly, when I talk to people, it seems it's about the control. So somebody wants to control everything that is happening, and this control is probably sometimes makes sense, but not always. So in reality, you get a big delay of feedback. So you make a whole feature, then submit a pull request, and then you send it to somebody to review, and you get the comments back when you have already spent a lot of energy and effort to build it all. So that's wrong. So you want to get feedback much earlier. So it's much better to actually go and talk to people if you're hesitant about how to implement something before you do it or while you do it. You invite somebody to review your code, not delay it until the end and then you wait for the pull request feedback. That is usually, as you probably know, comes in terms of style like comments, whatever, and very rarely there are bigger issues are actually spotted especially in bigger pull requests. So basically, pull request means that there is no continuous integration. So continuous integration is a really important thing from the Kent Beck book about extreme programming from like 25 years ago. So that's really crucial for the well-functioning, quickly productive team. So, and of course, you get merge conflicts because of all this branching and people not working on the same code base. So you tend to change the same things, and of course, after you have got several conflicts, you tend to change fewer things, meaning that you actually trying to implement everything using the old abstractions instead of refactoring something to the newer abstractions. So if you know that you need to refactor something, you know that, okay, I'm going to get a huge pull request, it's going to be reviewed very slowly, I better not do it. And most likely, if it's going to be reviewed slowly, everyone will be merging their own pull requests, and I will get a whole bunch of commits to work on after that. So it's hard for me to do the good thing, the refactoring. So if you're not doing pull requests, then it's easy to do the good thing, refactoring, because you're integrating it right away with other people. So yeah, that's like there's a lot of memes about the pull requests, and this one I think like says it's a lot of it. So basically, you don't get the quality usually from pull requests that you hope for. So it doesn't work. So there are more problems. So basically, it's easy to make branches, hard to keep track of them, hard to keep your code tidy, hard to refactor. So anyone knows about the Boy Scout rule? Yeah, some people. So basically, it's the rule from the Clean Code book that says that it's actually like Boy Scouts, when they come to the campground, they need to keep it cleaner than they found it. So if they found some trash, they just collect it, and when they leave, so the campground is in better shape than it was before. The same applies to code. So I always, when I read the code, I keep tidying it up, because you never get the code perfect the first time you write it. So while I read it, sometimes I find some variable names confusing. I just go and rename them while I'm reading the code, and I will commit and push it. It's very safe change. I'm making the code better. If I need to go through the pull request process for this tidying up, I would never do it, because it's just too complex. It's becoming too hard to do it. So, but if you just commit and push it, then it's easy. I'm going to do a lot more of it. So keeping the code base in much more healthy state. So yeah, the reviewing process, where I see an organization very often ignores the commit messages. So, and the commit messages is something where you actually write what you are doing and why you are doing it. And if you are reviewing the whole pull request as a whole big change, you're actually ignoring my reasoning about. So I need to write my comments again in the pull request. So why I've done it like that and whatever, but the information is already there in the commit messages. Of course, some organizations, they also say, but we squash the commit messages anyway. And actually by that, usually it's a practice that is even worse than pull requests themselves. It's actually losing the important history of where the changes are coming from. It's so much harder to reason about some changes, especially when you're investigating some bugs in production. So if you've heard about the libxz compromise recently, then actually it is hard right now to analyze all the changes done by a malicious, clearly malicious guy who actually committed to many open source projects, and some of his commits were squashed. So the history is now lost, and now it's much harder to analyze the whole impact of his bad things. So pull requests also, when I see it in teams, especially larger teams, so it leads to lower developer satisfaction. So people actually have to interrupt themselves and return to the same stuff over and over again, because while your pull request is in review, you're already doing some next changes, actually based on the old version of the code usually, which is also bad. So and then you get some comments there. You need to switch your context, you need to switch focus, go back to the old thing. Remember what was there, why I've done it like that. So it's like the context switching is not good for us humans. So it's bad for focus, bad for being productive. So the size of the pull request always also, there is like a whole articles written in when you try to reduce the size of pull requests, you usually get more interruptions, and that in the end actually leads to actually bigger pull requests. So there is like this kind of bad loop, bad feedback loop there. So, and when you're working on your old code base, as I told before, it's meaning that you're often like seeing like, okay, why this function is still like this? I already renamed it. I already like made it much better in my another pull request, but I'm still seeing this old version come up in another pull request. So, in another branch. So that's actually not leading to the like improvements, so it's really bad. Sometimes I did some improvements several times because I don't remember. I think I've done it, but I don't remember. There are like 10 pull requests open right now. Don't remember in which one of them I did it. So maybe I do it again because I needed this change in this branch as well. So that's not like nice thing to do. So, and yeah, always, usually there's more style-related comments than thorough understanding. So what could be the solution? So is that an AI reviewer? So there are startups now, the whole industry is being born to actually help you cope with the pull requests, but instead, the easiest way is just not to do it. So in case you have high trust, of course. So, but you still need to do code reviews, and code reviews are good. And this is an example how we do it sometimes in our teams. So we just once per day we sit together, we go through all the commits done in the last day. So and you can also do it remotely over some Zoom or whatever. So you go through the changes, you skip the more obvious ones, you discuss some of the less obvious changes. Sometimes you agree that you need to improve something the next day, and you just do it and you go on. So you're not stopping and losing time with that. So that leads to the collective code ownership, which is also an important extreme programming practice. So if you need to not deploy something that that you have developed yet to the end users, it's better to use feature flags, because the code in this case is already there in repository. Everyone is seeing it. Everyone can take it into account when they are writing their own code, and then you can actually enable the feature flags selectively on different environments. So you don't need to think about merging or not merging something and marinating your code. So Agile is about not working on unnecessary stuff. So you do only the stuff that is matters. So meaning that you are not developing a feature that you will not need in the next 6 months. So you better be doing something else that is needed right now, and you can change the priorities all the time. So it's not a big deal. We also use pair programming, of course. It's a bigger topic on its own, but pair programming also helps to do the code review right away, just there, and without needing to get back to it later. So there is also, if you're still hesitating and if it's difficult to abandon this practice if you're already using it, but if you're in a new greenfield project, don't start using pull request until you really see that there is a need for it. So the transition practice is led to divide your changes into ship, show, and ask branching. So ship, meaning that this is the stuff that you are confident, or a bug fix, or a tidying fix. So you are committing it directly to the main branch, and you're not returning back to it. So then there is a show thing that probably you've done something important that you want others to see and maybe comment as well, but you are not waiting. So you can create a pull request, you can send it to others to see, but you merge it right away. So everyone gets your changes, and the continuous integration is still working. And the last thing that is usually what people use with pull request is the ask style, when you are waiting for feedback until you merge. So this is if you are not confident in what you have done. If it's something completely new, you may use this strategy for some of your changes, but not all of them. So that's like the transitional idea. So you can read more on this URL. So yeah, now the second practice. So do you recognize this place? So that is Berlin. So there's one place like that right now in Europe as well. It's Nicosia in Cyprus. So it's a divided city, and let's keep dividing stuff to like unethical politicians and whatever, and we should not divide ourselves. So we should be working on our project together without the division. So really important rule in software development is that what changes together should stay together. So and that means how you structure your code as well. So you should not structure code by technical means. So there's again a lot of articles and stuff on that. So for example, if you have in your code like a package named controllers, services, and repositories, and you put everything into all domains into the same package, that is a wrong way of structuring. So you should structure completely the orthogonal way. And same goes with the front end and back end and the API and apps and whatever. So this is not how you should structure things. So in order to be really productive, you need to be more trying to be full stack, and you need to be able to implement the whole feature by yourself or by your like smaller team, like your pair mate or whatever. So basically you write some front end code, you write some back end code, you change your database, you push it, all commit, and the feature is works and delivered. So you can do it quickly, you can get feedback from your end users, customers, and whatever. So if you're splitting your work into back-end, front-end, and like even the services, then usually you're wasting more of the time waiting for other people to do the other part of the work. And then there is all the communication overhead and whatnot. So to be really productive, you need to be full stack, or you need to be like collaborating. If for example, you don't know how to write front end or mobile app code as well, really well, you just go find the one who knows it better. You sit together in a pair and you implement the feature, and that works perfectly, and that leads you to be learning stuff and being more productive in the future. So always structures things by domains and features, not by the technical means. And if you are keeping your, for example, front end and back end separately, don't forget that the big complexity that you are getting is that the version tracking and backwards compatibility. So if there's somebody else writing the front end for you, you always need to think, if I change something, will it break the existing code and whatever? There is no clear like compatibility things, and you will end up introducing more unneeded, unnecessary code. So the solution here is the application repo. So some people say, should it after that oh, it's monorepo. So it's not monorepo. It's not, at least not the Google style monorepo. Then they have everything that they have in the world in one single repository. That's probably is not a good idea, but you need to keep things which change together. You need to keep them in the same repository. That helps a lot to avoid the version tracking thing and to actually move more quickly. So you can, if you have, like, for example, mobile apps, also include them in the same repo, then you can really easily search for whole usages of your API endpoints. You can check, you can refactor them more easily. So basically, you in one single commit, you change your endpoint on the back end and also on the front end. You commit, done, you forget about it. You don't need to think about all kind of complex thing, how to synchronize this change with other teams and whatever. So you can also get a really big bonus. You can share type definitions between your front-end and back-end code. So you're always sure that you're using the same data structures, and the compiler will actually check it for you. So in the Java versus TypeScript or Kotlin TypeScript projects, I often use a generator that will generate like TypeScript definitions from Java or Kotlin classes, and you can cast to them on the front end, and then you are sure that all the fields that you are using actually exist. And then if you still haven't updated something while refactoring, the compiler will tell you the build will fail. So like you're saved. So you will not get this problem in production. So, and that of course empowers the whole team to do changes anywhere. So if somebody is even considering them more of a backend developer, very soon they start more and more getting into the other parts of the system, and that's always a bonus. More people looking at your code, more feedback, more like better results in the end. So number 3 is the lack of continuous deployment. So we've talked about lack of continuous integration before. So continuous integration meaning that people work on the same code base. So pull requests is the opposite of continuous integration. Then continuous deployment is then changes are not marinated for a long time. So your changes, when you've done them, when all the tests have passed, you deploy them, everyone sees them, so you get the feedback quickly. So it's also should be a no-brainer, but I've seen many teams who think that this is not important enough to actually get it working completely automatically. So if you don't even continuously deploy to production, because this is sometimes not depending on us developers, then at least you want to auto-deploy to demo server or something where all the team members who are working on the same project, like the business people, can actually always check and look at the latest version of the software you're working on and building. So then the next thing, so the microservices, of course. So this is when, like very often people have seen like, let's call it a big bowl of spaghetti. Or they often, if they have seen it in one project, then they instantly start a new project with the microservices, because they think that, okay, this time we are going to make it right, or at least we will prevent people from writing bad code. But of course, if you have the same people and the same practices and you apply them there, you get like many problems instead of one. So you always need to like still improve your practices first before going there. And there is a lot more complexity than here. So you always need to justify it. So there are legitimate use cases of microservices, of course, and but many teams who by default start with the microservices, they're doing it wrong. So never start with microservices until you have learned your boundaries and whatever, so how to split and why do you split and what not. So if you have seen a talk yesterday about mitosis, they shown a good way how to refactor your code first and then decide whether you go microservices or not. But the important thing is the structure of the code, not the deployment strategy, which is microservices. So if you have a really large team, like too many developers to work on the same code base, it may be a good idea to separate something. If until you have the collective code ownership, like team size of like 10 people or something, probably it's not the good thing to do, especially if you have the same people working on all the microservices. So, and if they're in the different repositories, you get the same problem as I talked about backend and frontend. So you get all the versioning fun. It's impossible to run everything on my machine and get the whole thing running and verify that it's all good. So no more working software, and this is also one of the agile values. So the software, if you cannot get it all working precisely and well enough on your own machine, then it will be pretty hard to get it running on production. So you'll need separate DevOps people, whatever, whatnot, and in the end you will start releasing and changing software much slower. So of course you also, with microservices by default, you get slower performance, because calling a method in the same JVM versus calling it through the network, it will be hundreds of times slower anyway. So you will pay a lot of penalty for that. So if you need more resources to run all your stuff separately, then you will also emit more CO2, and you're doing bad things for the climate. So this is also one of the things to think about. So it's harder to develop and test the whole system, version tracking, So it's much more harder to do work on a cross-cutting changes. So when the feature affects several services, and in my experience, I've never seen really well-designed microservices in most, especially enterprise organizations, when they started doing it from scratch. So they always do the wrong boundaries. And implementing one feature would require you to do changes in several services, meaning that you are again losing your productivity a lot is because of that. So Conway's law is something that is not going away. It says that your code structure and maybe deployment structure should actually follow your organization. So if you have a completely separate teams, completely separate business units, then it makes sense to actually do the services completely separately according to your organization. If your organization is all together, you're working on a single project, you deploy it for the same users, usually it's not the way to go. So never start with microservices. Learn the boundaries first. You can always get there with refactoring later on if you're not writing shitty code. And not writing shitty code is something that you should do anyway. There are things that actually can help. So basically, you can get most of the advantages of microservices by just splitting your code into domain-based modules within the same repository. So and make them also like a separate compilation units. Then you can enforce by the compiler, by Maven or Gradle, that, for example, you are not using like users domain is not using something from the payments domain, for example. So if you have them separate in your code repository, you compile them separately, you get all the benefits of microservices, so of not getting into the too much spaghetti, but you're not getting the downsides of slow performance, versioning, deployment, whatever. Of course, if in that case, if you have a good separation of your code, you can let people work only on some module. You change only one module. You run the tests only from that module, and then you can commit and deploy it, and you'll be pretty sure that everything is okay because you still have all the continuous integration and continuous servers and stuff verifying that everything works together. So yeah, deploy separately only when you have dedicated service teams and lots of simultaneous users. If you're Netflix, definitely you need microservices, but even one of the really huge services on the internet that we use all the time, they are not microservice based. Like take Stack Overflow. It's a good example of a monolith, really big service that works really well, and if it's well designed. So you can read on the internet about how do they build it and whatever. And there's also an interesting article by DHH about how to actually, if you are already in the microservices trap, how to get out of it, how to refactor your code back into monolith. So this is also a thing. Especially if you're a startup, you need to move quickly. It makes a lot of sense to actually get rid of microservices and actually work on the business needs, not on the technical problems. So number 5, technical debt. So this is something that I hear a lot in the teams, and especially in startups. So in startups, there is a problem of intentional technical debt. When people think, yes, we are not doing the stuff because we don't have time right now, so let's just do something. So it's the opposite of doing the microservices and stuff. So they're doing bad code intentionally, and in the end, of course, they are getting slower and slower and slower without doing the things properly. Of course, there can be unintentional technical debt as well. So it's just when you write bad quality code, then you just need to work on it, like talk to people, like use pair programming to teach them whatever to do the code better. But intentional technical debt is usually not a good thing. So very often it comes down to skipping tests. For example, don't have time to write tests, and then of course you're screwed after stuff when you start breaking things in production and you're just launching and you have your first users that get really bad impression and reputation. So Then, of course, the next thing that is very common in the pull request situation is that there is not enough refactoring. So you're starting with the smaller things, with the simplest things possible, and then you just either don't have time or it's too difficult to refactor and you just don't do it. You just put everything on top, on top, on top, and then you get end up with a monster instead of a nice software that is enjoyable to work. So you need to do continuous refactoring. That is really important. So before introducing any new feature or during introducing a new feature into the system, you always need to think, is the current abstractions enough for this feature, or I should change something in order to make it better fit into the design of the system. If you do it every time, then you never have to go to your manager and say, hey, we need to do only refactoring this sprint. And this is the worst thing we can do as developers. So we need to always doing the quality stuff is our responsibility. It's not the thing that we need to come to the customer and say, like, we've been doing really bad job last half a year, so we need 1 month to rewrite everything. That's not a good thing to do, not professional. So no big bang refactoring. Continuous refactoring is something that is much easier. So you don't never need to get permission to brush your teeth or something. That's the same with the refactoring. You just do it. You never talk about it. So that's the thing. Then in more legacy system, what I've seen is that there's usually a thing like holy database. And this is when the database lives its own life. It's being copied sometimes. They try to create other environments by copying the production database because nobody is able to reproduce the database from scratch. And what it means is that you're always like waiting for this shared database, shared development database. Everyone is working on it because it's too hard to create others. And it's hard to create a database on my own machine, which is the ideal situation because I need to have everything completely separate in my own machine to work effectively without others affecting my work. And if you have a holy database somewhere or a holy microservice or whatever, that will always lead to problems. So you always need to think about how to recreate your database, all the tables, all the schema, all the indexes. So basically not writing database migrations is a bad thing. And nowadays, hopefully nobody is doing that. There are still a lot of holy databases in the wild that sometimes you need to just spend a little bit of time to actually recreate the scripts to be able to create these databases really, really quickly. So, yeah. So it's good for testing and everything. Then number 6 is slow builds. So very often people say that, oh, why should I care? Like my application is built 30 minutes, but it's somewhere on the server anyway, and it doesn't stop me from working on my next feature. And that's exactly the same problem as with the pull requests, is that you don't get the feedback quick enough. So whether you've done everything properly, whether all your tests passed and whatever, and you will have to return back to it over and over again to make it all right. So you commit something, you wait for, of course you don't wait for 30 minutes, you just start coding something else, then your build fails, you need to interrupt, you need to again lose focus from what you were doing, get back to the old stuff, try to fix it. And if you're also doing the pull request, that's the worst nightmare that can be imagined for a software developer. So is that I saw in one bigger bank a situation when it was not possible to fix a flaky test during the daytime because of too many pull requests, and some of them were merged automatically. No, not automatically, but some of them were accidentally passing and merging, and they were merged back into old branches, and it was impossible to get your very needed fix quickly merged. So I had to put the do it in like 12 a.m. in the night when there is less developer activity to actually fix some of the things. So that's not a good thing to be. So slowness can come from dependencies downloading. So if you have too many of them, you can always optimize, cache them, whatever. You need to work on optimizing your build, and that will be really beneficial for the whole team, not losing a lot of time. So the slow compilation, you just split your code into separately compiled modules in the same repository, of course. If you have slow tests, then you just will see if you are probably running too many things in your tests, like, for example, you're initializing Spring contexts multiple times or whatever. You just can analyze it a little bit, improve it, and you will get much better feedback after that with the test. And the slow startup also is a bad thing for your application. That also is a problem for continuous deployment. If it starts slowly, it also is a problem for your own machine. So in Java, for example, if you make a change, some of the changes require restarts. And then if you need to restart stuff and it takes 5 minutes to start to verify that your change worked, it just kills your productivity. So you always need to invest time to make things fast, so you don't have to wait for anything. So if you even invest a couple of days investigating why your app is starting for 5 minutes, then you improve it, and then after that you will save like weeks of working time after that. So it's really pays to do it. So turnaround is really important, and seconds add up. Even if you have somewhere seconds of slowness, then during the daytime you will still have a lot of them. One option also is to convince the team or the managers or whatever to work on the slowness, is that you took the chess clock, and every time you're waiting for something, you just switch the chess clock. And then by the end of the day, you can see how much time you have wasted during that day. And that is hard data that you can use to like persuade somebody to work on it and make it better. So, of course, there are some things as well, like too many people on the team. So it can be like obvious, or like very often people think that the more people you put on the project, the faster you go, and usually the vice versa is true. So I've seen a project with 70 people completely like not moving forward at all. So and of course the managers thought, okay, we need to put 30 more, maybe then we can start moving. But of course that wasn't the case. So I recommended them to cut the team into half, and then that improved the things. So actually their productivity increased, because too many people, they always need to synchronize more. So in our case, like we usually assign like 2, 4, 6 people for a project, and they usually, if they are following all the practices of the extreme programming, being productive, like doing only stuff that is really needed, and then they can usually outperform 10 or 20 people doing the same thing. So think about it, how much more like things the people in your team could build if you just do it with smaller teams and like maybe do different things that are not too much coupled together. So people will always invent more unnecessary work. So the computers have become much faster over like the last 50 years with the Moore law. At some point they were like twice as fast every year. But people will have always found ways how to write less efficient code and actually kill all that additional productivity that the computers gave us, and still we get the systems which feel slow, even in 2024, when we have orders of magnitudes faster computers than we used to have before. So yeah, and if you're specializing narrowly, people will always find how to do stuff in the wrong, in their area of specialization instead of the correct one, and that also will reduce the productivity. So you should not be specializing too much. So when too much DevOps work, this also means that you are doing something wrong. So DevOps appeared, or this term initially meant that people would actually, you would not hire sysadmins because the developers would do the operations. But now DevOps is a separate person, like tuning Kubernetes YAML files. So that's not the initial idea that was there. So try to make it simple and try to do stuff in a simple way, like use just containers without Kubernetes or something to just reduce the needed work for the DevOps, reduce the amount of configurations and everything. So it's, look, for example, we host a lot of stuff on Heroku, like Fly.io and or like the container services to make things simple, so you don't need a lot of other dependencies around it, and make things also much faster, because we don't need usually microservices and things. And of course, with DevOps, usually you get vendor lock-in if you are going like all the way into some of the Amazon or whatever services. So you don't need specialized team members. Complex technologies is also a thing, is that you can choose technologies that actually look good on paper, but they don't give you enough value in reality. Like some of the simple examples is that you, like, for example, pick GraphQL instead of the simple REST, and you spend a lot of time solving GraphQL specific problems instead of like delivering features. Then like JVT very often is not thing you need, because all the crypto and something that you add there, maybe you just store a random token into the database and that will do it. Why do you need all the complexity of the JVT? Then Spring is also one of the things, especially the Spring security, is when it is much harder to actually configure it than to write the same code from scratch that does your security exactly what you need, that you can go through with the debugger and and be sure that you're doing the right thing, instead of like hidden bugs that can come from misconfigured frameworks and whatever. So, and Kubernetes, of course. There are lots of things like that. Of course, all the things, they have their own need and use, but it's not something that you always need to pick blindly. And the last one is too much code. Just try to write less of it. Try to write intentional code that is that actually is very clearly visible why it's written, why it's there, how it works, not verbose, and that's it. So overall, if you've seen something familiar, then it's never too late to change. You can always improve step by step. Just stop using some of the things that you don't see much value, and if it gives you more headache than the value, then probably you should eliminate it. So every practice is a choice. Remember that there is nothing like things that everyone should do always. So you always can choose which ones do you do or not. And thank you very much. You can get the slides from there. Unfortunately, we don't have time for questions, but I'm available here today and tomorrow, so you can come to me, we can talk about the details.